I'm doing. Can everyone hear me okay? Yeah, thumbs up. How's everyone doing? Thanks for coming here. So this session is something really exciting to us. We want to talk to you about something that is evolving, and it's also something that we are studying a lot. 6 months ago, the goal was to build the fastest agent. But now that goal looks a little bit different because the question is not just whether my agent works, it is about whether I can afford to run my agent 100 million times. As AI moves from frontier labs into your enterprise workflows, there is a need for intelligence to become dramatically cheaper so that that intelligence is a utility rather than a luxury. My name is William, and welcome to our session. I am with the Foundry fine-tuning team, and in this session, we're going to tell you everything you need to know about how you can turn your production agent traces into smaller models that will run cheaper, faster, and smarter. So if some of you were at our breakout session yesterday, you may have already seen this motivation for the topic because we have been noticing enterprise increasingly adopting agentic AI, and a lot of teams have already having agents in production today. The question that remains is that agents are inherently token consumption machines. It will consume a lot more token with all the tools, all the context, all the memories that you feed into the agent. So why do we need model distillation for this problem? Because model distillation is like an apprenticeship between two AI models. You start with a large, capable model, which acts as the teacher that solves real tasks. You collect many examples of how the teacher behaves from the real environment and use that data to train, in this case, fine-tune a smaller, cheaper model so that the behavior can be imitated. And after training, the student will handle the task at a fraction of the cost. And this is how you can have the secret weapon in your enterprise to turn frontier models into something that's tailored for your business at a fraction of the cost. So why do we learn from agent traces? Agent traces is becoming a unique field in the world of building agents. It's because this is one of the things that can tell us a lot, but not at the same time fully utilized. Agent traces are real conversations. So the traces will capture all the messy off-script questions that your users actually are asking, not just what you imagine them to ask. And the tool use is included as this process because the student will learn not just what to say, but which tools to call in what order, in what argument value. This is what makes the agent useful, not just a chatty chatbot to your users. And what do I mean by that also is that this extends to solving problem with the right trajectory. I'm pretty sure everyone has heard somewhat in your school that getting the right answer doesn't usually get you the full score because you can get the right answer but with the wrong method. And this is us trying to teach AI models to solve problems with the correct trajectory, with the real order of the tools, with the real argument values that the agent should learn to fill when they call the tools. So the traces also come with the benefit that it's easy to collect because if you're building agents on top of Foundry, we have already provided you all the tools that you need to collect them so they'll just come free to you at no cost. This will also grow automatically. That means if you want to have agent that gets smarter, the more you use it and the more your user interacts with it, this whole trace collection process will just run in the background so that you get something that's smarter as you go. And the last part is that this is more trustworthy than if you're just training data on synthetic data or some of the data that you think would work and represent the real world, because this is real signal that you get at no additional cost just by running your agent on Foundry. And going back to the topic of distillation, there are 4 wins that you can get from doing this. Number 1 is you can dramatically reduce the cost of running these models because you will essentially be running some of the very small models that sometimes you can even fit into devices. And also you can get faster responses. And these models, when you are fine-tuned on real-world traces, can sometimes often mimic very closely the teacher quality so that on the narrow task the student was trained for, the performance lived is substantial and sometimes even outperforming your teacher in some of the tasks. And also by doing supervised fine-tuning, which is what we're going to show you today, you are going to get more consistent behavior. So now, all of that is exciting, right? Everyone wants to see how that happens in real world, so I'm going to show you how that is going to happen so that by the end of this session, everybody will be experts about how you can just go back and do this. So this is what we're gonna do today, okay? So number one is we're gonna pick some of the tasks. These tasks are gonna be so difficult to the agents that some of the small, for example, 4.1 nano models will not be able to handle just by itself. We're going to use those tasks to simulate conversations between the teacher model, and this will give us a lot of the traits that will be generated as part of that simulation. And this is us trying to mimic in the real world. If you have an agent that's already deployed, you talk to it enough times, you'll have all these things that's just collected in the background, except in our demo today, we're going to simulate that for you so that it's able to fit into the time that we have today. And then you'll be able to clean the traces and use the traces to fine-tune the student. And at the end, you're going to evaluate and see the benefit from doing all of that. So who is excited? I'm excited to show you how we can actually do this hands-on, all right? So let's switch to my code. When I was doing this, the student model that I chose is 4.1 nano, very cheap, very fast, very nice to use. And the teacher is GPT-5.5. So who has GPT-5.5 in your production? How expensive is that, right? It's probably breaking your budget in a lot of times. And let's do something really cool here so that we can turn it into something that will run much faster and cheaper. So I'm starting to set up all the models that I have. I'm going to run an evaluation on 100 tasks. These 100 tasks are written in a way that is very challenging for base models. And this is one of the examples about what a task will look like. So we have 100 tasks, 80 will be used for training, and 20 will be used as holdout. Each task will be labeled in such a way that it will have a category. For example, in this way, it's like a late delivery interaction. And the customer is Noah, who is platinum tier and who bought a smartwatch, and I want a refund, and I think there should be a late delivery credit too. And the expected resolution is also tagged, right? It's delivered maybe 50 days ago, and then check the policy, and maybe you can get a refund, maybe you can get credit in this way and in that way. So this is 100 of these that we're going to use to simulate what you will see maybe in your real production scenario. So let's see how one of them is going to give a result. So this is running this conversation live. Imagine this is your agent that's already deployed, so you have this in your system, and just notice one thing here. Because I have so many tools, so many contexts, so many policy points, baked into my GPT-5.5 agent, just notice how long it takes to go through my database, to retrieve everything, to synthesize the results, to call the tool again, just to be able to answer one question. And you probably see this all the time, right? If you have used some of the coding agents, you will see, oh, it's like thinking now, and then I will go to bed, and maybe next morning, and something will come out of it. So this is a real problem, and let's see how we can improve on that. As you can see, it is still running. And this is a good time to talk about, so let's say we have all of these conversations that people are having with your agent. How can you know how good it is? We have to design an evaluation, right? You probably hear this a lot at build. Evaluation is the key. You have to understand how well something performs before you know how to improve it. So in this way, I want to evaluate in this 4 category. And remember, when you are doing this, you are free to design the evaluation however you want. So in our example here, I want to have 4 dimensions to score each conversation. So these are full multi-turn conversation I'm going to score. There's a decision correctness, which means the agent is calling the right tools, there's the right tool trajectory, there's the right financial accuracy when I'm calculating, and there's the right communication. So if I want to deny something, if I want to accept something, I want to make sure my agent says a certain keyword when it's communicating to the user. This is my evaluation criteria. And just let's see how the baseline looks. This is one example of how you are scoring this conversation, right? So as I said many, many times, you can design this however you want. In my case, I just want to make sure all the tool calls are expected in the right order. Financial accuracy calculation is good. Communication is good. And then each conversation will be scored in this way. Let's say how, if I do this for all of my tasks, these are all of my tasks, right? So this is a good time to introduce this score called pass K. So pass K means if you try K times, how many times you succeed, or how many times you score above a threshold that you think is acceptable, right? So if this is my task, and I'm going to run the same task on my teacher, on my student, on my fine-tuned student, 3 times each. So I'm going to run 3 times, and I'm going to collect a summary statistics at the end just to see how consistent it is that maybe if I try 1 time, I will succeed. If I try twice, I succeed twice. If I try 3 times, I succeed in all of them. So this is the score, the metric that we're going to be looking at today. And here is the result. This might be a little bit hard to see, but as you can see, the student and the teacher will have a very large gap. This means GPT-4.1 Nano and GPT-5.5, being 2 different models very largely in size, will actually perform really differently in its capability. But now, how can we make it better? Because you can see after I fine-tune my model, I'm actually able to lift my student performance by a lot, and sometimes even matching the teacher. And in my holdout, it's the test that I did to make sure that it's not just memorizing, but actually imitating the teacher's reasoning capability. And this is the result that we are able to get just by doing what I'm about to show you. This is pretty exciting, right? So imagine you can do this, and your 4.1 Nano is able to perform a lot better, and sometimes recovering more than half of the headroom that is available. If you are a visual person like me, you can see essentially how the performance is able to be improved a lot by just doing this kind of distillation work. This is great, right? And now, I'm sure everyone in your head is thinking, how do I exactly do that on Foundry? So let's switch to Foundry. You probably see this all the time over your other sessions. This is how you can build agents in Foundry. I have this agent that's already running here that I'm going to take one of the examples from my previous simulated conversation. You remember in the beginning, we had a customer named Noah. And Noah said this. I'm going to copy that. Put it here. So this is right. Your agent now is having Noah chatting to your agent. And then the agent, again, if you remember how much time it took, the agent 5.5 with all the tools available to it is going to think, it's going to look through all the data, it's going to go over all the context, and it gives you a response, right? So in a real world, imagine you have a lot of customers just doing this. What does this give you, right? This gives you something called trace. Trace is collection of everything that happens inside a request. Inside each one of your conversation turn, all the tool calls, all the reasoning steps, all the data flows, it's all here and visualized for you. And because Foundry has this capability to collect all these traces automatically, you will be able to see, after a while of running your agent, the collection of all the traces that you have, right? These are all of your real conversation from your customer. And now our task is to turn this into something that you can use to fine-tune a smaller model so that the smaller model will perform better. Are we ready for that? We have a create dataset button here under trace. Let's go to supervised fine-tuning. You can see it automatically collected all my traces from this time range. In this case, 1,000 or so. I'm going to give it a name. Hi build. That's my dataset name. And then I will click fine-tunings. What you see here is essentially you can automatically port all those agent traces into supervised fine-tuning dataset and start a run right inside Foundry by going to the fine-tuning tab. And under here, you'll be able to select supervised fine-tuning, 4.1 nano. You notice how high build now is the training data source, even though I just configured it. I'll be able to submit my job. And that is essentially how you can use agent traces to start. The first job is the one that I just submitted, the one that is queued. This is how you can use agent traces to start a supervised fine-tuning job. Everyone still with me? Yeah? Sounds good. And let's go back. I want to show you some of the results from doing that, because you may question, benchmark looks good, but what does it actually translate into your real world again, your real world value? And what difference does that make to actually go through all these processes? I want to show you some real results when I was doing my testing. And I was comparing the performance of the base model 4.1 nano and my fine-tuned version, which comes from that agent trace that I just showed you. And I want to see what actually is different so that my score is actually something that is fair and real. So this is one example. It's a restocking fee math example. So Diego argued that not liking the keys, which mechanical keyboard, I guess, he bought, is basically a defect, and I should not be paying a restocking fee. Because I'm standard tier, I do have to pay the 15%, so the correct refund is actually with the restocking fee. So in this example, the 4.1 nano base model, if you see when Diego was trying to convince the model basically, hey, I don't like your product, it's a defect. Can anyone notice what is wrong in this example from this particular response here? The 4.1 nano mentioned something that is very interesting, right? Since you told me it's a defect and you don't like it, I guess it's a defect. And since it's a defect, I'm going to go into your bank account. I'm going to pay this customer. I'm going to refund this person. That is not good, because the teacher 5.5 will be able to recognize correctly to reject this kind of request. And it can't be convinced in such an easy way. So what do I see here after I fine-tuned my 4.1 nano on the traces that come from 5.5? You see all the tool calls. And then you see here, it correctly had the restocking fee here, because it knows that no matter what you say, your reason is that I don't like it. It's not because my product is a defect. And in this way, imagine scaled by a lot of orders, your company can actually save a lot of the false refunds, right? How cool is that? So let me show you another thing. In this example, I want to show you when I say models can get to the right outcome, but not sometimes by the good method. And in this example, Liang wants to cancel the unshipped order with 2 items. Both are still processing, so the correct outcome is that you cancel both and refund. But notice something here, because my agent has a lot of tools, and one of them is to check the policy. Your agent usually has a policy, which is your refund policy, your business logic. Your agent is supposed to check this logic before doing anything, before submitting the resolution. But that, as you can see here, is not being done by the base model. I got the order detail, I got the fulfillment status, I submitted the resolution, right? Fulfillment is unshipped. So agent for a nano is like, since it's unshipped, I'll just go ahead and submit a resolution. This is fine, because in your evaluation, you are not gonna see money leaving your account in this case, but it is a very inherent risk if your agent starts to do things by jumping ahead and not following the trajectory which is deemed correct in your business logic. So in this example, by tuning on the traces that come from 𝗲𝗲, we were able to let for a nano to mimic exactly what the teacher was doing step by step. So instead of jumping right to submit resolution, I checked the fulfillment status. I found that yes, it's not shipped. I can cancel that, but just to be sure, I checked the resolution policy. And I called this tool with the right argument value, which the reason is to change, is a change of mind. And I want to check if this reason under my business policy is going to be applicable. And if it is, I'm going to calculate what the resolution is, any refund, all of the financial data, and I will submit the resolution, right? So in this case, you still get the right answer, but also at the same time, you'd be a lot confident, right? Wouldn't you? I would feel a lot more confident if my agent is like actually doing the right thing in the right order. No, everybody wants that. Another example of doing this, I have a sell item that is final sell. The water bottle is a sell item, and this customer complaint is it's not the same as advertised. So what is happening here? The customer is saying that since you told me your water bottle is going to keep my water cold for a certain time, but it's not doing that, so I'm not getting what I paid for, even if it's a final sell, this is a defect. Because it's different from my marketing, I want to convince the agent to refund me. So you see here when the customer is doing all of that, you see the customer saying, proceed with a claim for a defective item. The agent actually did issue a store credit, and the reason the agent deemed it as was that the item was defective. So this is another example of your customer in real life may do something that just never expected when you were designing the agent, and you want to make sure this kind of behavior is consistent. So in this example, we were able to improve consistency of your agent behavior. Let's see what the fine-tuned version does in this situation. It got the order detail. It got the fulfillment status. It was able to say, hey, I understand that you're claiming it is different from advertisement, but I don't think it's a defect. Unless you can show me it's a defect, I'm not going to give you any refund. And the last example I want to show you here is, you design your agent to do something, in this case, post-order support, and the person comes in and say, I want you to do something else that is out of scope. I want you to order something new for me. So in this case, your agent is not supposed to do anything. But for a nano, being for a nano, we'll look at this and say, I'll try my best and I'll do whatever. So it called the tool on check inventory when it's not supposed to. It should just recognize this intent and route separately according to your business policy, which is the behavior that we were able to accomplish after tuning. Yeah? It's pretty cool, right? To close it out, our work here really wants to motivate this idea that intelligence is something that you should find a way to be embedding into your enterprise, into your organizations, rather than treating the frontier models as a luxury commodity. And our work here is to help you to do that by using what you already own, your agent traces, your production history, all these trajectories that you can make use of so that you can optimize your cost performance by distilling agents, by distilling models, by distilling agent traces into smaller models that will run faster, cheaper, and smarter for your organization. I will be around for the rest of the day, but thank you so much, everyone, for coming. This is great, and really hope everyone enjoyed the session.